All right, guys. So the topic now is physical layer, and we're going to talk about some of the specifics of how the hardware and software uh, that relate to sending information through specific medium work, right? So I'm gonna use now this. I like this lightsaber pointer that I found in this app. So let's talk about how things work in the physical layer. So when I say the physical layer, I'm talking about how things work with the software and the hardware that actually handle how the bits and bytes are going to be sent through a specific medium. So in this computer, there should be some software or a specific set of instructions, right? Specific program that is going to be telling the computer how to send the information through this wire. And to do that, the software of the computer, actually the operating system of the computer, is going to talk to a specific device in here uh, that I try to draw here, which is the device that you find here, right? So where you actually put that wire on, when you connect it, you're going to find there inside the computer just one little device there, or one circuit there, that is called the network interface card, right? Now let's put it completely here, network interface card. Now this network interface card could be wired, I mean, could be for wire communications, or it could be made for wireless communications, right? So it could be a WNIC or just a NIC. And what that device or that hardware part is going to do is just going to take whatever information that is being sent from the CPU, right, through the I/O or the buffers to the NIC, so it can be sent through the wire, right? Now, um, this part of the software should understand what's the set of rules that are required to send that information through the specific medium that I'm trying to send. So if I'm using, for example, a wireless NIC, right? If I'm using the wireless NIC to send the information, then I probably need to know about Wi-Fi, right? I need to know what are the rules of Wi-Fi. But if I am talking about the wired, in most of the cases, if not all the cases right now, for a personal computer at least is, if you're going to send that through a wire, then you might be talking about understanding Ethernet. So Wi-Fi is for wireless as Ethernet is for wired. So usually this protocol now is implemented using this type of wire, the UTP, right? The unshielded twisted pair. And this type of wire would allow us to send information uh, to devices like this device that we have here, the switch. So the switch is just a device that um, connects different devices in a network. So let's say that this is the origin of the communication. So this is computer A, and I want to send this to computer B. And this computer B should be, if we're talking about the local area network, if we're not even talking about the internet here, we're just talking about the local area network, then we could say that I can connect this, well, using the jack here, right? I would just connect this to a NIC that is inside a computer. Let's say that this is not a laptop, this is a workstation or a PC, normal PC with a mouse and keyboard. And this device here in the CPU, or the where the CPU is located, it should have as well a NIC inside here, right? A device that, or a specific circuit inside the main board of the computer that is responsible for receiving and sending information through this wire. So obviously this NIC should also be aware of this standard, the IEEE 800 and 2.3 standard, which is the Ethernet standard, right? So obviously a language should be standardized because it's supposed to help people communicate or help things communicate, right? In this case, the set of rules is under this name, the IEEE 802.3, and that is just defining how the communications are going to be handled here. Now, what kind of things would you need to specify in this Ethernet protocol? Well, you need to define how the different bits are going to be arranged, right? Like if I am going to send, I don't know, 1 byte through this Ethernet, then I need to know, like, okay, look, you're going to have 8 bits for that, and then you're going to have I don't know, 24 bits for the MAC address of the computer where you're going to send it to, right? I don't think it's actually 24 bits. I think it's the MAC address is around, well, if it's 6 hexadecimal bits, it's going to be 12, like 48 bits. And then you have additional information like the checksum and all that. So you need, this protocol is going to tell me like how the data is going to be organized, so the other computer would know, like, or even the switch would know what to do with that information. The switch is going to receive, for example, a bunch of ones and zeros here, which it needs to know, like, oh, okay, you're Ethernet. I mean, you're talking Ethernet through this wire. Okay, so now I know that what you want me is to send all these bunch of ones and zeros to this guy, and you need to make sure using this checksum and all that. So the Ethernet is just going to say, okay, this is the way that you should communicate, right? It's like the language between these devices. So this guy should talk Ethernet, this guy should talk Ethernet, and this guy right here should talk Ethernet, right? Actually, the NIC here should talk Ethernet, the NIC here should talk Ethernet, and obviously the switch should talk that language, right? That set of rules. So besides like saying what's the data structure and what are the set of rules, one of the things that it would check is if there were collisions in the medium. Now, this was necessary for the old ways of sending information, and I want to tell you just why. Because back in the old days, when you were not even born, and computer networks were starting to be, you had this type of connection. You had just one wire, and I don't know, let's say 5 computers. They were all connected to the same wire. Not 5 wires going from, from here to here, here to here, or 10 wires I don't know. It would be just like one wire, and then you would connect all the devices to this specific wire, so this could be the medium for the connection, right? And so what they needed to do was to be able to define the rules for the communication just using one channel, right? So imagine if let's say that we label these devices A, B, C, D, and E, and I was going to send information from, I don't know, A to E. So I would start sending my bits and bytes right here. But if, this C guy wanted to send something to D, then it would try to send it in. If it was at the same time, then we would have a collision here. We would have a problem, right? Like, oh, you're trying to send and I'm trying to send. What are we going to do? Is your message going to be right or mine? Since here we had just, well, actually this is not like little dots, going through the wire. This is actually changes of voltage, like there are different signals here, right? So if I was like, let's say that this is the 1, this is the 0, 1, 0, 0, 1, right? So if A was sending to E a bunch of ones and zeros, and then the C started to send another thing, then maybe you would confuse the ones from one communications with the other, or you would try to nullify this one with a zero. Oh, it's a mess, right? So then you needed a way to find if someone was sending something through the channel through this wire, and if it was, then you would try to, you would stop your communications and say like, oh my god, there was a collision, there was a problem there, and now I'm going to wait. And it would tell everyone to wait. It would tell like, okay guys, there was a problem there, we had a, like a crash on the road, so everyone should stay home. Now it would actually work like in reality, like everyone would, say, okay, if the road is closed, then I'm going to wait, but they would wait different times, right? Like a random time for each one of those. And then after that time, they would try to access the same channel, right, again. But it would be wise to know, like, first check if there was a traffic jam or if there was a clash, right? So that's what the part of the protocol would try to do. And one part of the protocol was this protocol, the CSMA-CD. Carrier sends multiple access collision detection, right? So carrier sense is just carrier is just a medium, and sense is just like checking things, like, oh, I want to know, I want to listen and check if there are problems in the wire or not. And multiple access, well, because multiple nodes were trying to access the same medium, right? And collision detection would try to see if there was a problem in the connections in the networking. So the way it worked was just like very simple steps. Like, first, all the computers would be checking well, not the computers, the NICs would be checking if there was any problems with the medium. So if the medium was idle, like it was doing nothing, then you would then start sending information, right? If no one is using the road, then I can use it. But it would start using it and then start listening for a collision, like checking if there was a problem. Even while sending, it would check for a problem. So if there was no problem, then obviously it would try to keep sending all the frame until the end, right? It will try to send all the frame, all the structure, this frame here that we have here. And but if that was not the case, if there was a collision, then what it would do is it would send the jamming signal to all the devices, like saying, oh my god, there was a problem in the road, right? No one can use the road net right now, so everyone should wait. So when the collision happened, that's what they would try to ask every computer, like, everyone should wait now. And but it would also check how many times it has tried to go out of the house, right? Like, oh, I've tried 4 times to use the road, but it just seems like it's never going to be open, right? So the protocol would have like a top number of times, like, okay, you're gonna try, I don't know, like 5 times. Obviously this is a made up number, right? It's not 5, but it would try 5 times, and if the problem kept happening, then then we just give up and say like, okay, I'm not gonna try again. So I'm just going to report to the operating system, like, I couldn't send the information. You go and tell the application that was asking me to send this that I couldn't, right? Like the messenger saying like, man, the roads are closed and I couldn't get out. And but if that was not the case, if I still had some number of tries, then I would go back and check if there was a collision, and if there wasn't, then I would start sending, right? And after you send the whole frame, then you would go back and first you would check if you wanted to send another frame, right? So that could be obviously the case, because no communication would be just made of one frame. But if there was another frame, it would then start the process again. It would start asking if there was a problem in the medium and all that. So this protocol was kind of like famous in that time because it would solve the problem, but it was just made for this type of communications where you had, like, for example, bus topologies where you had just half duplex communication. Half duplex meaning that you could send information from A to B and from B to A, but at different times, right? You cannot be sending and receiving at the same time. That's half duplex. and when you had just one type of medium, right? The coaxial. But obviously, when the switches came, then this protocol CSMA CD was no longer necessary, and this Ethernet protocol evolved and made, there are very many different versions of this Ethernet protocol. There is like a history of changes in this Ethernet protocol. So nowadays we don't have that problem because we have things like the switches, and switches. What they would do is just they would create an actual path between those two computers that are communicating. So it would be just like one cable from one end to the other, right? This device is so smart. Well, not smart. It would just try to emulate just one single wire for any communication between any two devices, right? That's what it actually does. It switches connections and allows you to like have one wire from one end to the other. Now, this protocol is no longer in use, but if you're talking about wireless communications, then you might see that there is another similar version for this, which is the TSMA CA, which is just the version for wireless. And there is another, there is one specific part of that, which is the RTS CTS, which I'm going to leave you guys to check on your own because this is not part of the contents of this course. So this is just if you want to find out how in wireless you handle collisions. So that's just like extra work. But I think that's it for the things that I wanted to say about the physical layer. So things that I want you to remind is what's a NIC, right? What's the wireless NIC? What you think is Ethernet and what it is for. And inside the old versions of Ethernet, what was CSMA and CD? Sorry, CSMA CD protocol. And yeah, that's about it. All right. So I hope you guys understood this little section. And I will continue explaining with another video. I'm going to start explaining what a buffer is and how buffer communications work. All right. All right. So I think that's it. Thank you very much. And I'll see you in the next video. Bye bye.